Have you ever wondered how nature's hardest rocks are cut, shaped, and transformed into tools, buildings, and even industrial machines? Today, we're taking you inside a super giant cutting rock plant, where enormous slabs of basalt are mined, sliced, and crafted into something truly extraordinary: the basalt mill, a tool that has powered grinding, milling, and stonework for centuries. Before we dive in, make sure to hit that like button, subscribe, and tap the bell icon so you never miss more behind-the-scenes stories of how the world's most essential materials are made. Basalt isn't just any stone. It's one of the most common rocks on Earth, born millions of years ago from volcanic eruptions. When molten lava cooled rapidly, it hardened into basalt, a rock so tough it's been used for everything from ancient roads to modern skyscrapers. In fact, the Romans built some of their most enduring roads out of basalt, and many of those stones still exist today, nearly 2,000 years later. That durability is why industries still love basalt. It's hard, dense, and resistant to wear, perfect for making mills that grind grain, crush rock, or process materials in factories. Imagine standing next to a single block of basalt the size of a school bus. That's what workers here deal with every single day. The first step in the process is quarrying. Using diamond-tipped wire saws, hydraulic drills, and sometimes even controlled explosives, workers cut enormous chunks of basalt free from the quarry walls. The diamond wire saw works like a giant cheese slicer, slowly grinding through solid rock. It's strong enough to cut through basalt, a rock that's harder than steel in some cases. Once freed, these massive blocks are hauled out of the quarry by colossal wheel loaders and trucks. Each block can weigh tens of tons, requiring special equipment just to move. But these raw blocks are only the beginning. The real magic happens inside the cutting plant. The sound hits you first. The roar of saws, the hiss of water cooling blades, and the deep hum of conveyors. This is where basalt is tamed. The giant blocks are placed onto conveyor beds, where massive gang saws slice them into manageable slabs. These saws use blades lined with industrial diamonds, kept cool with constant streams of water. Without water, the heat and friction would destroy the blades in minutes. Once slabs are cut, they're moved to CNC, computer numerical control machines. These robotic arms can cut, polish, and drill the basalt with incredible precision. Whether the goal is a smooth countertop, a floor tile, or the circular shape of a millstone, CNC machines ensure accuracy down to the millimeter. Here, slabs are polished to reveal basalt's natural beauty, a dark, almost metallic sheen with tiny sparkling crystals inside. Some slabs are left rough, perfect for industrial uses. Others are ground smooth for decorative and architectural projects. Now comes the highlight: transforming raw basalt into a mill. First, workers select a high-quality slab with no cracks or impurities. Then, massive circular saws cut out the round shape. The stone is gradually honed into a perfectly flat disc. Grooves are etched into the stone's surface, carefully designed patterns that help grind grains or crush materials efficiently. These grooves are more than just decoration. They control how food moves across the millstone. Finally, the basalt mill is mounted onto a spindle or frame, ready for use in everything from traditional flour mills to modern industrial grinders. It's fascinating, a piece of volcanic rock, formed by fire thousands of years ago, now shaped by human hands into a tool that feeds millions. But basalt doesn't stop at mills. In this plant, basalt is cut into tiles, pavers, countertops, and even fibers. Yes, basalt can be melted and spun into thin fibers, creating a material that's stronger than steel yet lighter than aluminum. It's even being used in aerospace and construction industries. You might wonder, can stone be recycled? The answer is yes. Scraps and offcuts from basalt cutting are crushed into gravel or ground into powder. These byproducts are used in road construction, cement manufacturing, or even as mineral supplements in soil. Nothing goes to waste in this process. And because basalt is natural, non-toxic, and incredibly durable, it remains one of the most eco-friendly building materials on Earth. Behind every machine are people. Skilled workers who understand basalt's quirks, where it might crack, how to cut it safely, and how to polish it just right. For many workers here, basalt isn't just a job, it's tradition. In some regions, stone cutting has been passed down for generations. Families who once shaped millstones by hand now operate high-tech machinery. But the pride is the same. Take a moment and think. When you enjoy a slice of bread, step on a tiled floor, or drive down a highway, you may be experiencing the results of basalt. It's not just rock, it's a silent partner in civilization. From the dawn of farming to the rise of modern cities, basalt has been there, providing the strength, durability, and resilience we rely on. It's one of the toughest stones on Earth, yet humans have found ways to shape it, use it, and depend on it for thousands of years. And here inside this supergiant cutting rock plant, that story continues, where raw stone meets human ingenuity, and nature's toughest material is transformed into tools that keep our world turning. If you enjoyed this journey, don't forget to like, subscribe, and hit the bell icon to explore more amazing behind-the-scenes stories of how the world's essential materials are made. Every year, billions of plastic bottles are discarded around the world, piling up in landfills, floating in oceans, and harming ecosystems. But what if we told you that these same bottles can be given a second life, not as more plastic, but as something entirely different? Today we're taking you inside a modern recycling facility where innovation meets sustainability. From the moment a bottle hits the sorting line to the final bales of fluffy polyester fiber, this is the journey of how trash becomes treasure. Let's begin. The process begins long before the factory floor. Across cities and towns, used plastic bottles are collected from curbside bins, public recycling stations, and even from manual pickers scavenging landfills. Once gathered, the bottles are transported to a material recovery facility, MRF. Here they are unloaded in massive heaps, thousands of pounds at a time. The first step? Sorting. While PET bottles might look similar, not all plastics are created equal. Machines and human workers work together to separate PET, polyethylene terephthalate bottles, which are ideal for polyester production, from other plastics like HDPE or PVC. High-speed conveyor belts carry the waste under a battery of sensors. Infrared scanners detect the resin type. Optical sorters distinguish color. Air jets blast non-PET items off the line. Caps and labels, typically made from different materials, are also removed. Some facilities use label stripping rollers or even laser cutting machines to do the job with precision. Once sorted, clean PET bottles are ready to begin their transformation. Before anything else, the bottles must be thoroughly cleaned. Contaminants like food residue, glue, or dirt can severely affect the quality of the final fiber. The sorted PET bottles are conveyed into a granulator where rotating blades chop them into small flakes, roughly the size of corn kernels. These P flakes are then sent through a multi-stage washing system. 1. Cold wash removes loose dirt and residual liquids. 2. Hot caustic wash. A heated alkaline bath breaks down stubborn adhesives and sanitizes the plastic. 3. Friction washers. High-speed paddles scrub the flakes against each other to loosen contaminants. 4. Float sink tanks. Since PET sinks and other plastics float, this stage separates leftover caps or labels. Once washed, the flakes pass through centrifugal dryers that spin at high speed to remove surface moisture, followed by hot air dryers to lower humidity content below 1%. At this stage, the clean, dry flakes resemble plastic confetti, pure, uniform, and ready for the next phase. Now it's time to turn flakes into pellets, the feedstock for fiber production. Clean PET flakes are fed into a twin-screw extruder. Inside this machine, the flakes are heated to around 260 degrees Celsius, 500 degrees Fahrenheit, just above PET's melting point. Mixed and compressed through rotating screws, melted into a viscous, honey-like liquid. As the molten PET exits the extruder, it passes through a spinneret, a metal plate with tiny holes, to form thin strands. These strands are cooled in a water bath, then chopped into uniform pellets using rotary cutters. Each pellet is about 3 millimeters wide, compact, consistent, and easy to store. These recycled PET pellets, also called rPET, are now ready to be transformed into polyester fiber. In the fiber production unit, the rPET pellets are transferred into hopper-fed extruders, where they're reheated and melted once again. The molten PET is then forced through another spinneret, this time designed to form ultrafine continuous filaments, each as thin as a human hair. As the filaments emerge, they are quenched with cold air to solidify, pulled at high speed to align molecular chains, increasing strength and durability, coated with an anti-static or finishing agent to improve texture. This process is known as melt spinning, and it's the same technique used for virgin polyester. But here, the source is 100% recycled. The filaments then pass through draw rolls, heated rollers that stretch them to the desired diameter. Depending on the end use, the fiber can be engineered to be soft and fluffy for stuffing, or strong and coarse for textiles. The continuous filaments are then crimped, given a wave-like texture to improve loft and blending ability. Finally, the fiber is cooled and cut into staple length, short segments that resemble raw cotton. These are baled, weighed, and stacked, ready for spinning into yarn or direct use in filling materials. Quality is everything in recycled fiber production. Each batch of polyester fiber undergoes rigorous testing in on-site laboratories. Tensile strength checks for durability. Elongation tests measure stretchability. Moisture regain ensures the fiber behaves like virgin material. Ash content detects contamination. Advanced facilities also test for optical brightness, color consistency, and chemical residues, ensuring the fiber is safe for use in everything from apparel to bedding. If a batch fails any metric, it's either reprocessed or rejected. This strict quality control is essential for consumer safety and industry standards, especially when fibers are used in sensitive applications like baby products or automotive interiors. Once baled, the polyester fiber is shipped to textile mills, insulation factories, and consumer goods manufacturers worldwide. Its uses are diverse and growing. Textiles, blended with cotton or used pure to create t-shirts, jackets, socks, sportswear, and jeans. Home furnishings, stuffed into pillows, mattresses, and upholstery. Automotive, used in soundproofing panels, seat padding, and linings. Construction, mixed into insulation and geotextiles. Every ton of recycled PET fiber saves roughly 6,000 plastic bottles from landfill and reduces the carbon footprint by over 50% compared to virgin polyester. Brands across the globe, from Adidas to IKEA, now rely on recycled polyester to meet their sustainability goals. Consumers, too, are increasingly seeking products that close the loop. The impact of converting plastic bottles into polyester fiber is more than just technical, it's ecological. Each year, plastic pollution claims thousands of marine lives and chokes ecosystems. But recycling PET into fiber reduces landfill overflow, lowers greenhouse gas emissions, cuts reliance on fossil fuels. Yet challenges remain. Contamination in collection, lack of sorting infrastructure, and public awareness gaps still limit recycling rates in many parts of the world. To scale impact, manufacturers are investing in advanced use them every day to pack our lunches, store leftovers, or deliver takeout. Plastic food containers are everywhere. But what if we told you some of them were made from yesterday's trash? That soda bottle you threw away last month, it might be holding salad today. In this episode, we go behind the scenes to uncover how discarded plastic, once destined for landfills or oceans, is collected, purified, melted down, and reshaped into safe, durable containers fit for your fridge and your microwave. From curbside bins to cutting-edge machines, and from dirty waste to food-grade clean, it's a journey of transformation that combines recycling, chemistry, and precision engineering. This is more than just plastic, it's a second chance. Welcome to How It's Made, Recycled Plastic Food Containers. The journey of a recycled plastic food container starts long before it reaches the factory. It begins at the curbside. Across neighborhoods, cities, and commercial zones, used plastic bottles, food packaging, and containers are dropped into recycling bins. These items are then transported to regional materials recovery facilities, where the transformation begins. Upon arrival, the plastic waste is unloaded in massive piles and pushed onto conveyor belts. The first round of sorting is mechanical. Large spinning drums separate light materials like film plastics from heavier objects. Magnets pull out any stray metals. Then comes the key step, optical sorting. High-speed infrared scanners detect the type of plastic based on how each piece reflects light. Once identified, powerful air jets separate PE, polyethylene terephthalate, from PP, polypropylene, and so on. These are the two most commonly recycled plastics used for food containers. Manual workers follow, picking out non-recyclables, dirty items, or anything that could contaminate the batch, like greasy pizza boxes or foil. The selected plastic is then grouped by polymer type, color, and grade, and moved into separate holding bays. Any container that once held chemicals, paint, or hazardous material is discarded, because only the cleanest feedstock can become food-safe again. Once sorted, the plastic heads for a thorough washing and shredding process. But even at this early stage, the path from trash to table has already begun. Once the plastic has been sorted by type and quality, it moves into the next phase, transformation. Large conveyor belts carry the selected plastic into a granulator, an industrial shredder with sharp rotating blades that pulverize bottles, trays, and containers into small flakes, each about the size of a fingernail. This process dramatically increases surface area, making the next steps more efficient. But before these flakes can be remade into food-grade containers, they must be spotlessly clean. Shredded plastic enters a friction washer, where high-speed paddles agitate the flakes in a mixture of hot water and biodegradable detergent. This removes any residual food, labels, glue, and surface oils. Now that the plastic flakes are clean, dry, and sorted, it's time to turn them into something new. Plastic pellets, the building blocks of nearly every plastic product made today. The flakes are fed into a twin-screw extruder, a long cylindrical machine that both heats and mixes the material. Inside, giant rotating screws push the flakes forward while raising the temperature to over 250 degrees 482 degrees Fahrenheit, hot enough to melt plastic, but not to degrade it. As the plastic becomes molten, it's forced through fine mesh filter screens that remove any remaining microcontaminants, like tiny bits of paper, glue, or metal. The pressure and filtering here are critical. One flaw could compromise an entire batch of food-grade product. The filtered plastic then exits the extruder in long, thin strands, often called spaghetti. These strands pass through a cooling water bath, solidifying as they travel along a moving belt.